All right, welcome to the last time we're going to look at the slides for arrays and vectors. Let us finish them up in this lecture. And there's only one lecture this week, of course, because of the midterm. So let's do good stuff. So the last thing we were talking about is how to reverse a vector slash array. So given a vector of indeterminate size, we notice that we need to swap the zeroth thing and the last thing, the first thing and the second to last thing, in that order. And the number of swaps total that we wanted to do is always size over 2. Okay, let's turn that now into an algorithm. Okay, so let me make a file, and let's make a vector. Let's use vectors. Let's reverse the contents of a vector of ints, and let's have it hold, I don't know, 7 things. Something different than what we were doing last time. Okay? And so now the question is, what do I do from here to reverse the contents of V? Alright, so here's my V. V holds 1, 2, 3, 4, 5, 6, and 7. And the idea is, let us iterate using I starting at 0. So we'll worry about the left indices and then calculate using math those right indices that we want to swap the left ones with. So let's do that. We'll start I off at 0. Okay, so that's the first index we want to worry about swapping with the mirrored side, the very last thing, right? And then we need to figure out how many times we want I to do stuff. How many times do we want this loop to iterate? How many swaps do we need, right? So it's size over 2 swaps, so we want the loop itself to iterate size over 2 times. Okay, so now the loop's going to iterate size over 2 times. For this one it's 3, so it's going to swap this one, and then this one, and then this one with its counterparts on the other side, skipping the 4. Okay, and now the question is, what do I do here? So I'm swapping index I with, I don't know, the index on the other side, right? Index to swap with. What's the other side, okay? If you stare at this long enough, there's a pattern based on I. How do I get v dot size minus 1 based on I being 0? How do I get v dot size minus 2 based on I being 1? Well, it's always v dot size minus 1 minus I, okay? See how if it were minus 1 minus I, it would have been minus 2 here. That's the pattern. Okay, so it's always swap indices I and size minus I minus 1. Okay, v dot size minus I minus 1. Those are the 2 indices I want to swap. Index I and this one. Okay, and yeah, this is going to work every time we notice that, because it's going to skip that middle index if it's an odd number. Okay, size over 2, just integer division gives that to us. All right. And so we're going to iterate as long as I is less than size over 2. It's going to make sense, and it's going to work. And so for us, again, 7 over 2 is 3. Okay, we're going to go with I staying strictly smaller than 3 for this particular vector. Okay, and so now all that's left to do is swap. Swap the value at this index with the value at this index, and we remember how to do that from last time, right? So int temp equals v at I, let's say, and then I want to swap v at I with v at index to swap with, whatever that is, and then make sure to put into that right side index the thing I was saving away in temp. Okay, and so that'll do my swapping, and then I'm going to iterate that many times, and by the end of this I'm going to have a reversed array. Isn't that cool? So for int e and v, let's print out every element in that vector and see if it correctly got swapped. Yay, there it went. Isn't that cool? And it works no matter the size. Even if it's an even size vector, our calculations are still correct. We're iterating the proper number of times. It's all going to work out. So this one also works. Okay, let's put it back to 7 though. Okay, so let me walk you through what's happening and why this is working. Okay, so stare at that code, understand it, and let me walk you through how this is working. So I starts at 0, of course. I is staying strictly smaller than size over 2, which is 3. And so we're going to swap index I with size minus I minus 1. 0, 1, 2, 3, 4, 5, 6. Size minus I, so that's 7 minus 0. That's 7 still. Minus 1 is 6. So I'm swapping this index with this index. And so that's what we do using temp as an intermediary. It's like, okay, we put into temp the value 1, change 1 to 7, and then make 7 what was in temp. So 7 and 1. Okay? And then I++. I becomes 1, still smaller than size over 2. So I'm going to swap index I with size minus I minus 1. So 7 minus 1 is 6, minus 1 more is 5. That is correctly in that index. See that? And so we'll end up swapping these, 6 and 2, using temp to do the cool stuff. And then one more time, because I is going to stay strictly smaller than size over 2, so I gets to be 2, and that's it. We swap index 2 with index size minus I minus 1. So size is 7, I is 2, so size minus I is 5, minus 1 more, that's index 4. So we're swapping those guys, playing our game 5 and 3. Okay? And so that, hopefully, convinces you why this is going to do the right thing. It's going to swap those elements of the vector. Okay? So this is a fun, good example. You're going to be caring about reversing things a lot in your computer science career, I am sure. So definitely study up on this algorithm. It's a fun one. Okay, so that's reversing things in either a vector or an array. It works exactly the same with arrays, right? You just can't use .at anymore. Yeah? So now I want to give you a chance to think about some things, just to take stock of everything we learned about arrays and vectors. Okay? So write down on a piece of paper, try it in code on the server or something, but write down how to do each of these things for both arrays and vectors. Okay? How do you access an element at an index of a vector and an array? How do you initialize to hold 1, 2, 3? How do you create a new array or a vector of size 10, holding 42 in every index? All right? How would you do that? Okay? And you can just think about it, write it in English, but it's very good, it's a good practice to try all of this. Okay? So, assuming you're back and you've thought about it, how do you access an element at an index for an array? It's always an array, and you use the square brackets, array at I. And for a vector, you use .at, the at I, right? To initialize, to hold 1, 2, 3, you can, well, for an array, you can be like, you can be lazy, you can be declare it, and then add into it later, like set the values later. Or you could be int r equals, well, remembering the brackets, and then you give it the 1, 2, 3. That could work. For a vector, you can make an initially empty vector and then keep on pushing back stuff, right? Push back 1, ... Or you could also do the style for a vector as well. Okay? You could say vector int v equals 1, 2, 3. That syntax also works for vectors. Okay? So you got options if you want to initialize it. And then, how do you make an array a vector of size 10 holding 42 in every index? Well, I have a feeling the easiest way to do this for an array is just like int r of size 10, and maybe in a for loop, go through each index and put 42 into it, okay? Then, like, for ... That would be probably the way that I do it. You could also just hard code 42 a bunch of times. That also works. And then for a vector, you could make an empty vector and then push back 42 a million times, 10 times in a loop. That would work. Technically, there's also a secret way to do it for a vector. Definitely look up the documentation page for vectors, because you can do really cool stuff. But there is something called a fill constructor for vectors. Here is one way to make a vector of 10, size 10 with 42 in every index. You just say this. Isn't that neat? So there's a way to fill 10 indices with the value 42. That's a cool, different way. It's a shorthand for filling in a bunch of values in a vector. Okay? So definitely look up the documentation page because it tells you how to do this and more. Okay, so that is officially all that I want to talk about right now for vectors. I want to get into arrays again, okay? A special kind of array, right? I want to talk about C strings. C meaning the language C, the one that came before C++ that C++ is based on, okay? And to differentiate it between, to differentiate this from the string type that you know and love, that lives in the string library, that I'm going to lovingly refer to as a C++ string, okay? That type is a C++ string type. I'm going to teach you about the old style, the C string type, because that's still used in some places, okay? So, let's get into it. A C string is just a different kind of string type. It holds a bunch of characters, right? We prefer to use our C++ string type, okay? But sometimes we have to use a C string for certain things, certain features of the language, okay? A C string, the way that it stores its stuff, it's really just an array of characters. It's a special kind of array of characters, though, okay? Here's what a C string is. Let me show you first what a C string is not. This is an array of characters. It has HELLO, right? That is not a C string. What is special about a C string is that there is a special last element, always, okay? It's always the character \0, which is supposed to mark the end of a C string, okay? Let me draw that, and I write it down there later too, but this marks the end. It's a special character. Marks the end of the C string, and this is so common to want to do, to write the string hello as a C string, which is a special char array. The double quotes actually make a C string, not a C++ string. It gets converted on the fly for you when you make one. But this syntax is shorthand for this array, believe it or not. It includes that special null terminator character. That's what it's called. \0, that character, it's called the null terminator character. And it marks the end of a C string. Okay? So this is a correct, either of these options is a correct way of making a C string. And here's what it looks like in memory. It's just an array of characters, so it's got H, E, E, L, L, O, and the \0, the null terminator character. Okay, so that's what it looks like in memory. And C++ knows how to print this. Like, so I could give a C string to cout. I could say cout stir, and it would be fine with that. Okay? It has no problem with it. So let me show you this. Boop. So let's make char stir equals H, E, L, L, O, and then null terminator character. Okay? A C string. Char stir2 equals hello. Equivalent to the above. Shorthand. They're both the same though. So I can print them out. Cout stir space stir2. C++ knows how to print C strings. Has no problem with that. So hello, hello. Not bad. And yeah, you can, because they're arrays, you can go in and change the characters. Totally fine. You know, access at a certain index, change it. Make sure that you keep the null terminator character there though, because otherwise C++ doesn't know when the string ends. That would be a problem. Alternatively, instead of saying this kind of type, char and then some brackets, the type of C strings is, if only I could spell type. There we go. The type of C strings is char bracket bracket, kind of, right? An array of characters. A special one with that extra character at the end. Sometimes, instead of writing this, people write this, char star. Okay, you might see this in the documentation. These are equivalent types. I have not yet taught you what the star means yet, though. We'll get to that later in the class, I promise. But just read this as equivalent to an array of characters, okay? For now. And with that, I'm ready to teach you some cool C-string library stuff. There's a library called C-string that does cool C-string stuff. Also, C standard library has some cool stuff as well. Let me show you a few different examples of C-string functions. So let me search for that. C++ C-string. Here we go. Let's see, the first one that I want to teach you is A2I, and I think that's the one that's in C standard library. So let's go there first. cstdlib. A2I. This is very, very helpful. Let's click on it. It takes a string, see, a C string, char star, and it gives you back an int. Interesting. That's quite nice. So it takes a C string and gives you back an int so that you can do int stuff with it. Okay? That's super nice because, of course, you can't do the same things with quote for as the number for, and you can translate between them using A2I. Okay? Let me show you that. So eventually, I'm going to need these cstdlib and cstring. So here is a C string, I don't know, str3, s3 equals the string 42. I can convert this to an integer, s3 as an int, using A2I. It takes a C string and converts it to a number. So I can do number stuff with it. Isn't that nice? I can like multiply it by 2. And obviously that would not have worked with C strings. Yay. So it takes a string and it converts it to a nice number so that we can do number stuff with it. Okay? Alternatively, there is an S2I function that also works. It works for C strings and C++ strings. That's in the string library, S2I. So you can look that one up too. Your book might talk about it also. So that's A2I, converts a C string to an int. Strcat is a weird one. Cat stands for concatenate. That just means put next to something else, put two things together. Strcat is essentially the plus operation on C strings. Okay? What you do is you say strcat. You give it two strings. It's the plus equals operation, really. You give it two strings like this, S1 and S2. That is equivalent to the C++ string operation S1 equals S1 plus S2. Okay? That's just going to put S2 at the end of S1 and modify S1. All right? So one thing that you have to be very careful about, because remember that arrays cannot change their size, you have to make sure that the first string is big enough to hold all that extra stuff that you're about to put in it by concatenating stuff. Okay? So char S4 equals hi, and maybe I want to put S5 at the end of that. I'm going to say hi mom in total, right? This needs more room, right? So let's force it to be a very long array, okay? Give it enough room to hold, to hold more characters, because strcat is going to need more room. S4 and S5. What that does is it sets S4 to be itself plus S5, okay? And so now S4 is bigger. It holds hi mom. That's a C string operation. Yay. And so we had to give it some extra room to hold extra characters after these, because we're putting more there. So that's strcat. Strlen makes a lot of sense. It gives you the size of a C string. That's in the C string library. There it is. Dun, dun, dun. Way down here. Just gets the string length. Takes a string, gives you back the size of it as just a number. You can interpret that as an int. And so, let's see here. What's the size of str2? Hello. That is strlen str2. And that'll give us 5, which is interesting to think about because really it has that extra character here that is not counted in the length of a string, we say. Even though you need a size 6 array to hold it, it says, strlen says that it's a size 5 string, how many real characters are in it, okay? So that does not count. The \0, that's the one weird thing about it. And then finally, probably the weirdest standard library function has to do with comparing C strings, strcomp, okay? So let me show you that one, it's here. Strcomp compares 2 strings, takes 2 strings, and returns an integer based on how they compare, which is really weird to think about, okay? Here's how it works. If the strcomp function returns a negative value, that means that str1 was smaller. If it returns a positive value, that means str2 was bigger. If it returns a 0 value, weirdly enough, that means that the strings were equal, okay? So the return value, the value that you get back by using strcomp, is weird. Very, very weird. But it compares in dictionary order, just like for normal C++ string comparisons. But, oh man, does it return weird things. Let me show this to you. So, let's compare A, B, C to, I don't know, B, C, D. So the first one's smaller. Let's compare B, C, D to A, B, C. So the first one is bigger. And then finally, let's compare ABC to ABC. Remember, this is C string syntax, so it works just fine. And I think I'm going to need some new lines, so let's do that. And these final ones are equal. So here's the kind of stuff that it returns. So you got to watch out for that. So it returns -1 when the first one's smaller, +1 when just any positive number really, when it's bigger, and then 0 if they're equal strings. Crazy. So you got to watch out for that. If you want to have an if statement using C strings, seeing if they're equal to each other, you say if strcomp those 2 strings is equal to 0. Weirdly enough. Okay, so this is a lot of old things, old types from the C language, but they're still around today, so we have to learn about them. Okay, so that is C strings in a nutshell. And I included this fun picture because of the difference between quote 4 and 4. The first one is not an int yet. Got to convert it. Okay, so the reason I'm teaching you about C strings is because there's one feature of C++ that still uses them, that still requires them, okay? It's based on the way that the Linux operating system runs a program. It gives it some things as a C string, as an array of C strings, in fact. So let me show this to you, okay? So let me build this up because command line arguments are really, really cool and useful. You might have been wondering how to use them, so let me teach that to you. So we run our programs like this right now. It's // the name of the program, right? But like when we use G++, we get to put stuff after the G++, after the program's name. What? I get to say stuff like G++ and then space, more stuff. C++ 17, foo.cbp. When I use cd, the name of the program, it takes extra stuff, the things that I want to change directories to. We can do that. We can make it so that our programs can respond to us running it like this. /program 42 space high. We can let that happen, okay? That is how it works, okay? And the reason it's called command line arguments is because we pretend that the name of the program is a function, okay? That's why it's called command line arguments. Pretend prog is a function. And you're trying to do essentially this to it, right? You're trying to be like prog 42 and high. That's why it's called command line arguments. And here is how it works. Our program really, it's allowed to see everything that we give it on the terminal when we're about to run it. It's allowed to see the 42 and the high, even though we're not using it. Like right now, it's totally valid for me to try it, like C strings, blah, 42, blah, some more. It still runs the program. We're just not looking at this stuff right now. Let me show you how to look at it, okay? How to get that information from from the program. The trick is to define your main function in a different way, okay? You have two options when you declare a main function. We have been using the first one, the easy one, int main, immediately close off those parentheses, and then do our stuff. If we want command line arguments, we can declare, if we want access to them, we can declare the main function in a different way. We can say int main, of course, and then in those parentheses we can say int argc. These names can be anything, but these are their normal values. And then char star argv bracket bracket, which is ugly, I know. And then you give your implementation. Okay, so this is the alternate way of declaring a main function, and you can give it these two extra things, and these are two extra variables that you get to use. Okay, here's what's going on. The first thing is called argc, stands for argument count. I'll use rainbow for that one. Is argument count. That's what argc means. And the second one is more complicated. This one says how many arguments were given to me on the terminal. So it counts the name of the program. So for this one, it would have given me 3. Program 42 and high. There are 3 things that the user typed and gave to us. And then this one tells us what those things were. Okay, you read it like this. So here's what argv stands for. It stands for argument vector, not the C++ vector, just vector as in a bunch of stuff together like an array. It really is an array, but people call it a vector. That's why they introduced this term. Again, you can give this any name, but most people call it argv. Arg count and arg vector. Okay, and what is this weird looking type? Okay, argv is a something of somethings. Okay, it is an array. That's what this means. It's an array of, what is this? I'll use a different color for that. It's an array of C strings, right? That is how you read that type. argv is an array of C strings. It's very weird to read it, but this is how it works. argv is an array of C strings. So it's a bunch of C strings. It's all of these things that we space separated when we ran the program. That's how we access through argv the contents of what we typed along before we pressed enter and ran the program. Okay, so if we just define our main function like this, we have access to our stuff. Isn't that cool? So let me make a program that just prints out argc and then every valid element of argv. Okay, here's how it's going to work. So let's see here. How do I want to explain it? Maybe I'll make the program first, and then I'll talk about what's happening here. Okay? Command line args.cpp. And so instead of this main, I say int argc char star argv bracket bracket. Okay? So this allows us to get command line arguments. And remember that argc is the number of command line arguments, and then argv is the actual command line arguments as a bunch of strings. Okay, so are you ready? We have access to them. So for example, if I were to run this program, I compiled a program, called it prog, and then I ran /prog and then space separated these things, 1, 2, high, and mom. Then argc would be set to 5, because it counts how many, 1, 2, including the name of the program, 3, 4, 5. argc would be set to 5, and then argv would be an array of C strings holding the contents of these different things that I space separated. Okay, argv would get set to this. The first element, the 0th element, would be /prog. That's the first thing that I typed on the terminal. And this would be 1, 2, index 1, 2, 3, and 4. Okay? it would hold as C strings all of these things that I typed along, okay? The text of all the stuff that you typed, even if they're numbers, right? So if you want to use them like numbers, you're going to have to convert, okay? So here's the first one. I'll just make a program that does this kind of thing, that goes through the command line arguments. So if I were to run it like this, hopefully you can see that. Whee! I'll call it something like this. And if I run it with these things, argv will be set to 1, 2, 3, 4, 5, including the name of the program, 6, and then here are the contents of argv. Okay? That's the kind of thing that I want to do now. So we'll print argc, and then for int I equals 0, I is less than argc, because argc is the size, right? You want to go strictly smaller than the size. Those are our valid indices into argv. Cout argv of I, okay? And I want to print that I'm going into that index. So cout argv of, and then the index, colon space. Let's do it that way. Okay, so this will print argv of I. The contents. Are you ready? So, oops. So I'm calling it command line args this time, and then I can give I can give as many spaces as I want, 3, hi mom, as long as there's at least one space that separates them. This is how it works. Okay, so again, argc is going to be set to the number of arguments, so 1, 2, 3, 4, 5, 6. There's 6 of them. And then that means argv 0 through argv of 5 exist, and so this is what they contain. It's just a bunch of C strings, the text of all those things that I typed. It got rid of all the spaces, of course. Okay? And so that's what it holds. That is how you access the command line arguments. Very useful, right? Let's use the command line arguments to draw a square. That will be a cool little example. Okay? So let's use the command line arguments to draw a square from the user. Okay? So this is how we kind of want to run the program, /draw square with the size of that square. Like we want a 5 by 5 square. Okay? So what does that mean? Argc should be, let's make sure that the user gives us the right number of command line arguments, right? It better be exactly what? Think about this. Because argv should hold this and this. What does that mean argc should be? It should be 2 because it's counting both of those, right? This would be index 0, this would be index 1. So argc better be 2, okay? And then the number that we care about, right? The number that will tell us how big of a square to draw, that's an argv of 1, okay? That holds the width of the square that we are supposed to draw. Okay? So let's make that program. Draw a square using command line arguments. So draw square.cpp, and let's get access to those command line arguments. So int argc char star argv bracket bracket. Okay? And so what I'm going to eventually do is the width is in argv of 1. So let's get it. Int width equals argv of 1. And remember that I can't do this. This is a string. I'm trying to assign a C string to an int. I can't do that without converting it, right? So that's what cstdlib and the a2i function is for. Okay? Gotta convert it to an int. Okay? And once I've got that, then I can do, I know what width is, I know how to draw a square of a size, right? For int I equals 0, I is less than width, I plus plus, and then I will, for int j equals 0, j is also less than width, j plus plus, draw a single star, and then a new line, just like that, okay? So this is almost right. It's going to work if I do it correctly, but I also want to guard against the user giving us bad stuff. Whee. So right now I can say draw square of 5, and it works. Draw square of 3. Oops, it took the 3 still. Draw square of 3, 4, 2. It's all fine. It's getting the number out of argv1 and then doing stuff with it. But right now I can also do this. 242. That seems weird. Why should I allow that to happen? That seems like the user's using the program incorrectly, right? And I'm also allowed to do this. Boop. Oh no. Runtime error, because I didn't actually have anything in argv of 1 this time. Okay? So we want to make sure that the user gives us the right number of command line arguments. Okay? So here's what we can do. We can make sure that it was correct. So if argc is anything other than 2, the user did the bad. The user did something bad, and they ran the program incorrectly. Okay, we should say that. Okay, that's what you usually say, and then you can stop the program. Return 0 or exit 0, either way, you want to stop the program early. Okay, and so here's what that'll look like. That'll make it so that we can't do anything weird. See, you need to provide exactly 2 command line arguments. And then same with, this still works, but if I do 242, again, I gave too many this time. You need to provide exactly 2. You could also say, you can give guidelines as to how you should have run this program. Here's the proper usage that you should have used. You should have said /draw square and then exactly 1 number, okay? How do you get /draw square? That is secretly sitting in argv of 0. Hey. And then space, I don't know, n, okay? Where n is a number. New line. Isn't that cute? Because argv of 0 always holds the way that you ran the program. If I had a different name to the program, it would get that still. That's wonderful. So here I go, draw square 242. It's like, you should have done it this way. And it took the /draw square from argv of 0. You should have done this with an n, where n was a number. Okay? And again, it still works fine. Isn't that fun? So that is how you can look at the command line arguments to see if you got the right amount, and then once you know that, you can run the rest of your program. Okay? Remembering to convert from C strings, because it's an array of C strings, to the numbers that you need. Okay? So that's draw square, and let's see how we're doing. All right. So yeah, that is all I want to say about that. What I'd like to do, and there seems to be enough time, let me show you an example of all this. Let's write a program that takes command line arguments and outputs them after doing the following things. I want you to try this, maybe. Pretend it's a crushed ice. Try this yourself, and then I'll implement it right now too. Okay? So take a bunch of command line arguments like, I don't know, ./prog, blah, hi, 42, all that stuff. And what I want you to do is maybe output everything, output all this stuff, or maybe just the arguments and not including the name of the program. You should capitalize every letter using like 2-upper in CC type. Like we want to output this. Capitalize every letter, so it's going to be yelling at us, all caps blah, and then we can shift every digit as well. So instead of hi 42, we can say hi 53. Won't that be fun? So that is kind of what I want us to do. Okay? So let's try this. That's a fun example. So let's use command line arguments one more time to, I don't know, capitalize and shift .cpp. A fun little way of doing it. More stuff with command line arguments. So let's make sure that we get them. We're ready to get argc and argv. And then, well, let's go through, starting with the things that the user typed in, not including the name of the program. So that starts at argv of 1, right? So 0, 1, and 2. So all the way from 1 onward, I is less than argc, I++. Now what I want to do is capitalize every character in argv of I, and then also shift every digit in argv of I. Okay, that is how I want to do it. So here's what we can do. So we want to go through, we want to iterate through argv of I, right? So for, what's the best way I can think about this? For int j equals 0, j is less than strlen argv of I. Maybe you want to use a second variable to put argv of I into something new. It doesn't matter, this still works. J++. And we want to go through and now update argv of I at index j. That's the character j of argv. Isn't that cool? That would work. But this is starting to get complicated, so maybe let's do it this way. Char star, I don't know, s. This is the string that we want to work with. That's argv of I. So let's do it like this. And now we'll update s of j. It's going to be the same thing, though. Okay. And then we'll do strlen. But in order to use strlen, we need cstring stuff. And we're also going to use cc type stuff. Yeah, so this is a non-trivial program to write, but it gives you a lot of practice using command line arguments and cstrings. Okay, so here I am iterating through every character that isn't the null terminator character of this string s. We're going to update s of j as necessary. So if s of j is an alphabetic character, is alpha, is true for it, then we want to capitalize it, right? Otherwise, if it's instead a digit, s of j, then I want to shift it. Does that make sense? So s of j here equals 2 upper s of j. And then here, if it's a digit, I want to shift it up by 1. So s of j equals s of j plus 1, as long as it's between, and this is going to be where it gets a bit weird, as long as it's between 0 and 8, right? Because if it's 9, I got to make it 0 again. Does that make sense? And that it doesn't wrap around properly if I don't do it. If I do it like this. But this is one way to do it. Add 1 to the ASCII code and see if it's too big. But let me just do it the silly way, the way that doesn't quite work. And I'll have you think about maybe how you might make it perfect. Okay? So update s of j if we need to. And so now I've changed some characters, potentially all of them, in s. And now s has been changed. Let's output s. So I'm not going to test you on every little thing about C strings, but this is a great example of a bunch of stuff, doing random things to it. Okay? So here I am, going through everything other than the name of the program. So I ranges between 1 and argc minus 1. And then the string that I care about, I want to work on, is argv of I, right? That's the string. And I'm going to use char star, because that is another way to talk about an array of characters. And then I go through every index of that character, or of that string s, just like this. See if that character is an alphabetic character. If so, capitalize it. Otherwise, if it's a digit, shift it by adding 1 to its ASCII code, because the numbers go in order, right? This is going to do something weird with 9, but every other number is going to be proper. And then finally, let's output the string s. So that's my little contrived example to end the day on. There it goes. So I gave nothing. It did nothing. If I did like I had it before, blah, and then high 42, right? Yeah. Yeah, I get blah and high 53. The one thing that doesn't work properly is 9. Apparently after the 9 character in the ASCII table, there is a colon. You'll have to use an if statement to fix this up a little bit. This is not quite correct for that 9 digit. But for every other digit, it is correct. Okay? So study this. It's a fun, kind of complicated example, but it's more practice on nested loops too, huh? All right, so that's capitalize and shift. That was fun. And that is officially everything that I wanted to talk to you about for arrays and vectors. So you are now experts, and you can use them in your programs. All right, so that is the only lecture for the week. I am also, though, because we just finished arrays and vectors, going to give you a lab about them. Okay, so let me release lab 4 now. So I'll be going and recording that video. So I'll see you there.